Hi there, welcome to this user session. My name is John Prendergast and I'm here with my colleague Thomas, who will shortly bring you through the detail of this particular user session. We are both part of Accenture's Finance Analytics Centre of Excellence, which has offices in Dublin, which is my own office, Poland, where Thomas is based, and in the US also. Our practice's main areas of expertise are split into four main pillars: digital finance transformation, financial crime and regulatory compliance, fraud, and the pillar from which this particular use case sits, risk. Since 2011, we have been helping customers across industries and use cases shape and design solutions to help them address their pressing problems within these areas. Some examples of which would include the providing of an in-depth, actionable cost and profitability-based insights to CFOs, the ensuring of an efficient adherence to regulatory criteria within banking, the provision of the capabilities to holistically prevent and detect fraud at an enterprise scale, or providing high-value data-driven approaches to addressing credit risk, bad debt, and our collection strategies. There are many offerings within these pillars where we have been delighted to partner with SaaS. The powerful and flexible SaaS solutions and technology stack can both enable and enhance our analytics methodologies and operating model for the enterprise, allowing us to apply our own IP as well as leverage the out-of-the-box functionality and power of a SaaS-driven solution. What we would like to bring you through in this user session is a methodology we have applied within the telco industry to help minimize the bad debt that can be accrued by a telco operator's customers when additional third-party services are made available to them to purchase using the account balances of their existing subscriptions. This double-edged sword for telcos introduces new revenue streams, but also opens the door to additional credit risk and greater opportunity to incur bad debt, both of which increase the cost to serve. We want to address this efficiently and with minimal impact to the customer journey. We recognize that the market is swamped with technologies and solutions that claim to address these challenges, but often at a significant cost. We want to highlight to SaaS customers that you can maximize your ROI from your existing SaaS investment and tackle the root cause of challenges such as this rapidly without introducing new overhead for systems, resources, and processes. So, Thomas, please, if you wouldn't mind stepping us through this customer-proven solution.
Thank you, John, and hi, everyone. Over the next part of the presentation, I will be diving deeper into the solution and how we can use SaaS to solve many of the problems John just described. Before we go into the technical and methodology aspects, let me elaborate on the challenges we have observed and what kind of benefits we expect to bring by implementing this solution. To purchase content and services using existing subscriptions, customers can have different spend allowances allocated that are relevant to them. This is to protect clients from incurring bad debt from non-paying customers and ensure relevant allowances are assigned. We found client challenges when using ad hoc analysis and reporting, disparate sets of information which could be scattered across tools and areas. There can be no automated analytics framework to support with ongoing prediction of bad debt or to recalibrate predictive models, and the process of setting allowances for subscriber segments might not be automated. This introduces significant amount of manual work and incorporation of business rules into the process that can lead to limited realization of revenue, increased bad debt, and reduced customer experience. Implementation of solution using SaaS manages to solve many of these problems. The data required for analytics is centralized with all data integrated in one place. Analytics framework is put in place to enable generation of up-to-date models predicting bad debt and then to optimize allowance allocation. This data-driven solution can bring significant benefits with expected excess of up to 40% of bad debt reduction and expected increase in revenue of up to 30%. Also, due to the automated nature of solution, a substantial reduction in manual effort can be achieved, expecting up to 60% of manual effort reduction. The solution is based on three key fundamental concepts. The data, integration of data from various data sources, and establishing processes to monitor data quality. And this is coupled with having data flowing, processed, and transformed into the solution automatically. Analytics, having bad debt predictions based on newest data without need for manual or ad hoc analytical activities or involving additional personnel to conduct data science activities. Also, to have automated recommendation of the best subscriber allowances using optimization engines. And finally, the ability to consume the outputs by business users easily through providing all information visually in one place, including portfolio analysis, projection of revenue and bad debt across models and scenarios. And this allows for streamlined decision making for the client based on the analytical outputs. Based on those underlying fundamentals, we have created a reference architecture. The solution consists of 5 integrated components, and over the next slides, I will go into some aspects of individual components. But first, let me show how the solution was implemented using selection of SaaS tools. The first one being data ingestion and processing, where we have used base SaaS with development done using SaaS Enterprise Guide. The module covers pipelines for ingesting of data, feeds, processing and transformation of the data, and also preliminary aggregation of data, which is coupled with automated analysis of the data quality to detect any issues or unexpected variances in the data. We have leveraged SaaS access interfaces that enable to tap into databases of different vendors and types. We have found using mixture of pass-through functionality using SaaS access and processing data in SaaS using 4GL work very well. Large volumes of data can be processed natively or pre-aggregated before bringing into the solution for further processing. The second key component is the customer analytical record, or in short, CAR. CAR is a fundamental data structure for analytics and predictive modeling. It is a wide table with hundreds or even thousands of variables aggregated on customer or subscriber level. CAR is built using advanced data transformation and aggregation, oftentimes on multiple levels and in multiple stages. And here, again, we have used SAS 4GL to process the data on all the necessary status and aggregation levels. The third component is the bad debt prediction component, which is to build predictive models for targeting bad debt. We have used predictive algorithms from SAS Stat, but also use SAS Enterprise Mariner for preliminary models build and discovery of the trends in the data. The algorithms were embedded in automated framework, allowing models to retrain themselves. And the framework was created using SAS Enterprise Guide, using SAS 4GL, and the algorithms from SAS Stat were embedded into the framework. And while we have observed very good results with the standard algorithms just available in SAS Stat, more advanced algorithms from Enterprise Miner can be further introduced into the solution to enrich and further refine the analytical outputs. And the fourth component is the engine for optimization of the spend allowance for subscribers. Again, we have used base SAS here, and we have developed a custom grid search algorithm for this purpose. The algorithm enables to search for optimal allowance scenarios across various subscriber or customer segments and leveraging predictive models. And here we were able to optimize the calculation process through extensive use of SAS 4GL language. This process also generates artifacts that are needed to enable what-if allowance scenario simulation. And the visualization component, the solution provides a set of actionable dashboards with information feeding from the other components of the solution to visualize all required outputs such as predictive models logic and models performance, interpretation of risk segments and trends that lead to bad debt, projection of revenue and bad debt, and the use of the simulation functionality. Importantly, this solution is embedded within automated framework or components run and propagate the information automatically through the components. And this was achieved by extensive use of SAS macro language to automate elements such as SAS code resolution, parameterization of the solution, execution, and propagation of the information automatically through the solution. For example, the predictive models build uses macro to loop through multiple hyperparameter settings, select best performing models by looping through different test sets and propagate the model logic to the next stages. As you can observe, this solution can be implemented just by using standard tools commonly available in many existing client SaaS environments, while additional tools can further enrich the solution to refine the outputs. Over the next slides, I will go through a bit of detail on the aspects of the components. The first step in the solution is the integration of the data from the sources through automated processing and preparation to serve as the foundation for the analytics, optimization, and the visualization purposes. There are four key elements: data ingestion, integration. It captures and integrates data from different sources. New incoming data is captured automatically and incorporated into the solution. The second, onboarding of the new categories into the solution and automatically propagating those through the solution components. The third one, data quality analysis, automatic detection of deteriorating data quality and raising alerts if any anomalies are found or detected in the data. And this is important to prevent the solution from generating outputs based on inaccurate or potentially incomplete data. And the fourth, it's the advanced transformation aggregation to generate structures for optimization, visualization, and CAR. And the CAR is the product of advanced data processing and can consist of hundreds or even thousands of features to provide comprehensive view of customer or subscriber. It can cover different informational areas such as product history, content usage, and consumption, core network usage, or the external or third-party data. And since CAR build, this is usually an iterative process, it is important to initially understand which data to use. This can be achieved through preliminary analysis of the data, like understanding correlation between data elements and bad debt, through business expertise existing at client by assessing now and hypothetical factors, or by leveraging reference card designs based on previous implementation experience. Next, let's jump into the automated framework for building predictive models targeting bad debt. The solution leverages CAR as a foundation for predictive model training, and the CAR is automatically rebuilt on most up-to-date data on a given frequency. Additional calculation and transformation, such as target feature calculation, it's also part of this stage. The model self-retraining. Different algorithms can be used to train models, starting from more traditional methods like decision trees or regression models, to more complex ones like gradient boosting or neural networks. We have observed very good results by even using the traditional methods. Another consideration is the features to be used for the modeling. Certain algorithms will select best set of features along the training procedure, but feature space can be reduced upfront before introducing into the framework through methods like variable clustering or correlation analysis. This may limit the ability for the models to pick up new emerging factors, but at the reduced ability to compare models and their logic change over time, which can potentially reduce interpretability of the models. And on the interpretability, the model performance is compared, and best models are selected based on the statistical performance measures such as Gini index or KS statistic. For this, the custom testing method was developed to ensure that performance is thoroughly tested by training and testing models on multiple partitions of the data. The model logic is visualized along with all information to understand model performance and to profile segments of different risk. Also, bad debt patterns and trends are visualized to provide insights into key indicators leading to bad debt. And this kind of level of information is needed to give confidence in the models and results that are produced, even more importantly, considering the self-training nature of the modeling process. The last analytical component is the optimization engine, and the optimization enables to select best allowances for customer or subscriber segments in terms of optimizing the revenue and bad debt. The engine consists of two stages. The models that are built using the automated framework are used to derive segments of varying levels of bad debt. Then additional level of the segmentation based on other features is applied. And since solution onboards new categories, these would be automatically used within the segmentation and optimization process. This stage also includes calculation of the projected revenue, bad debt across the segments and allowance scenarios. And for this, we have used a custom implemented methodology. We have also implemented the custom grid search algorithm to select the best recommended allowance scenario across the segments. Due to the potential for a significant number of segments and scenarios to improve to improve the computation time, we have integrated the projection of the revenue and optimization procedure into a custom methodology implementation. This also enabled to generate the artifacts for performing what-if simulation at the same time while running the optimization procedure. And lastly, the visualization, providing all outputs from solution components into single place to enable informed decision through set of actionable dashboards. And this includes visualization of the logic of the model, performance of the models, interpretation of the risk segments, trends, and key factors leading to bad debt. Also enables to project impact on bad debt and revenue from using newly produced models. It gives the simulation functionality to enable what-if analysis of scenarios and comparing them with optimal scenario and the current portfolio view. And this provides the transparency to streamline the decision making and having confidence in the analytical outcomes generated by the solution. And this concludes walkthrough of the solution, and thank you for taking time into learning about it. Now, let me hand it over back to John for the final wrap-up. John, if you wouldn't mind giving us some final thoughts.
Great. Thanks a lot, Thomas. Very insightful. I think it's really interesting to see how you can use this approach to move along the entire analytics lifecycle from initial assessment and problem qualification, which can help us see the size of the prize, to discovery, where we can build a business case and estimate the complexity and feasibility of different approaches, all the way through to proving the value and, of course, then industrialization. I think coupled with agile working and the utilization of an analytics pod team, so a team of cross-skilled team members, this can ensure that we can either fail fast or continually progress and build value. So a lot of what you described there resonates with me from my own experiences, as I've used similar methodologies and approaches for other business problems. In fact, this can be applied to other bad debt use cases, also to many other fraud scenarios, such as the fraudulent use of authorized push payments. Also, more recently and very currently relevant, for identifying, monitoring, and simulating coronavirus impacts, including assigning customers to relevant bandings or categories with associated treatment journeys, whether this be to simulate the impact of the sudden surge in digital customers on fraud systems, or the impact of the spike in payment diversions, for example, in banking, the increasing non-performing loan rates, etc. or to assess and predict the vulnerability across different customer segments to the huge increase in fraud scams and cyber attacks during the pandemic. An approach such as what you have shown, I think, can really help accelerate getting insights in these areas and bring that all the way through to the value realization of industrialization. So, in summary, during this session, we have shown how by using a simple SaaS architecture, we can build a full deployment of self-retraining models and optimization as a solution to a particular bad debt optimization related problem. This model allows telco organizations to effectively minimize losses due to bad debt, reduce the cost to manage that bad debt, and increase overall ROI in this lucrative revenue stream. By leveraging existing SaaS investment coupled with taking this data-driven analytics approach, an organization can apply similar methodology to accelerate to the insights required to make decisions and address many business problems. So that is the end of this user session. I hope you've learned something or found this interesting. From myself and Thomas, many thanks for your time and have a great rest of the day. Thank you.